Okay, so first problem we have here is we have the frequency of a violin string is varying inversely with the length of the string. So our general equation then is going to be that the frequency is equal to some constant k divided by the length of the string. Plugging in, we get that the frequency 450 is equal to some constant k divided by 35, which means that k is equal to 35 times 450, which is equal to 1,000 or 15,750. Okay, so now we can use our equation, which is that f is equal to 15,750 over L to figure out a value for f given L or L given f. In this case, we're told that the string is 30 centimeters, so we want to figure out what the frequency will be. So we will plug in and get that the frequency equals 15,750 over, in this case, 30. And that's going to give us that the frequency is equal to 525, and that is in the unit of cycles per second. Okay, in our next problem here, we have that the distance a body falls varies directly as the square of the time it falls. So our general equation will be d is equal to k times t squared. And that means that we can plug in to get 144 is equal to k times 3 squared. So 144 is equal to 9k. And then k is equal to 144 over 9 is equal to 16. Okay, so now we can use our general equation of d is equal to 16t squared and plug in for d given t, or solve for d given t or t given d. And in this case, we're given that t is 7 seconds, so we end up with d is equal to 16 times 7 squared, which is equal to 16 times 49, which is then equal to 784. And in this case, our unit is feet, so 784 feet. Okay, moving on here. We now have some of our simplification problems. And so now we're going to set up two radicals. And in the first radical, we're going to have everything that's a perfect cube. And in the second radical, which we are multiplying by, is going to be what's left over. Okay, so we know that 96 is equal to 3 times 32, or 2 to the 5th. So 3 is not a perfect cube, that goes here. 2 cubed is a perfect cube, so that goes here, which lays us 2 squared. We look at our x, and we have x cubed as a perfect cube, which leaves us x squared. Y to the 7th, well, y to the 6th is a perfect cube, which leaves us y. And z cubed is a perfect cube, which leaves us 1, so we don't write that. And then we take the cube root of everything in this left radical, and that's going to give us 2x y squared z, and that's just multiplied by everything left over here, which is 6x squared y. Okay, so now the same thing over here, except that our two radicals, or rather instead of the third root, we're dealing with the fourth root. So we're looking for numbers that are perfect fourth powers. And so again, out of the 3 times 2 to the 5th, which we saw back here, the 3 goes over here, we get a 2 to the 4th here, which means that we're left with a 2 here. We get an x to the 4th here, which means we're left with an x to the 1st, or x, times a y to the 4th, and then that leaves y cubed here, times, nope, can't pull anything out of z cubed, so we just have that over here. And so we then take the fourth root of everything over in the left radical, and that gives us 2xy times the fourth root of 6x y cubed z cubed, and that is our final solution. Okay, for the next one here, solve for x. We're going to end up multiplying both sides by 2x and 2 minus 5x, which means that we're going to do the equivalent of cross multiplying, which means we're going to end up with x minus 3 times 2 minus 5x is equal to 2x times 2x plus 1. And when we expand, we're going to get 2x minus 6 minus 5x squared plus 15x is equal to 4x squared plus 2x. We'll reorder and combine on the left side. We get negative 5x squared. We have a 2x and a 15x, so we get plus 17x. And that's minus 6 is equal to 4x squared plus 12x. 2x. So then when we're going to make the left side equal 0, so we'll add 5x squared to both sides to get 9x squared. We will subtract 17x from both sides to get negative 15x. We will add 6 to both sides, and we'll then divide everything through by 3 to get 0 equals 3x squared minus 5x plus 2. And can we factor this thing? Well, let's try. So the only way we get 3x squared is by 3x times x. And we know that we can only get 2 by doing negative 2 or positive 2 and times each other. So negative 2 times negative 1 or 2 times 1, and they would have to be negative to get a negative 5x. So if we put, let's see, negative 2 here, negative 1 here, that gives us negative 2x. Yep, this works. So we end up with x then is equal to 1 or 2 thirds. Okay, well, suppose that we hadn't been able to factor this, then we would have used the quadratic formula, which would have given us that negative of negative 5 plus or minus the square root of b squared minus 4 times our a value, which is equal to 3, times our c value, which is equal to 2, all over 2 times a, or 2 times 3. That would give us 5 plus or minus the square root of, and we're going to get negative 5 squared is 25, 4 times 3 times 2 is 24, so we end up actually with just the square root of 1 all over 6, which gives us 5 plus or minus the square root of 1, or just 1, over 6, which means we get 6 over 6, or 4 over 6, which is equal to 1 and 2 thirds. Same thing that we got back here, fortunately. Okay, so let's go on to our next problem here.